All right, still all about our triangles. Today we are going to talk about two congruency theorems. We have more than just two, but we're just going to focus on two today, and we call them SSS and SAS. So let's dive right in. All right, if three sides of one triangle, so all three sides of one triangle are congruent to all three sides of the other triangle, then the triangles are congruent. This kind of goes back to our parts and parts CPCTC. So if the three parts of the sides are congruent and these three parts, triangles are congruent. So we call this side, 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 because side, side, side on one, side, side, side on the other, congruent. And we abbreviate that with SSS. All right, so what does that mean? We got our two triangles, A, B, C, and D, E, F. So this side is congruent to this side, this one is congruent to this one, and this one is congruent to this one. So these two triangles are congruent by side, side, side. Remember, the order matters. So if we're going to start on that first triangle with A, B, C, then we have to match the corresponding parts to D, E, F when we are writing our congruency statement. All right, if two sides and the included angle of one triangle is congruent to two sides and the included angle of another triangle, then the triangles are congruent. And I'll show you what I mean by included angle. We call this side angle side, since we're talking about two sides and an included angle, meaning that angle's got to be in the middle of those two sides, or we abbreviate this with SAS. So what does that mean on our triangles? So we got our two triangles. We're looking for side angle side. So if this side is congruent to this side, and this side is congruent to this side, there's our two sides. The theorem says the included angle, so that means that it's got to be in the middle or in between or included with those two sides. This could not be angle C or A or angle D or F. Okay, it's got to be that one in the middle of the two sides that are congruent. Remember, let me tell you one more time. The angle needs to be in the middle of the two sides that are congruent. All right, example, state whether the triangles could be proven congruent by SSS or SAS, then write your congruency statement. So what I like to do is I like to take it, look at what's congruent from one triangle to the other, and I like to write down an S or an A. So we got this side right here is congruent to this one. This angle is congruent to this angle. This side is congruent to this side. So we've got a side there. So I write side, angle, side on that triangle. And I've got a side, angle, side on this triangle. Is that angle in between those two sides? Yes, it is. So this is our side, angle, side. Another example. So remember, if we've got two triangles placed on top of each other like that and they share a side, that side has to be the same. It literally is the same exact line. So we've got this side is congruent to this one, this side congruent to this one. Since those are the same exact line, that means that if I pulled those triangles apart, that side right there would be congruent to the other side on the other triangle because I'm pulling them apart and they have the same exact side. So that's our side, side, side because we got three sides. All right, this side is side and it's congruent to this side. And we got this angle congruent to this angle and this side congruent to this side. Okay, so we've got side, side, angle. If I read it the other way, we got ASS, angle side to side. Because that angle is not in between those S's, this isn't congruent, or we don't know, there's not enough information. So remember, if you see written out on your little triangles, ASS, mark it out. There is no such thing as ASS. So we say that these are not congruent, or there's not enough information. You can say either one, not congruent or not enough information. So practice with these two theorems before we move on to all of our other theorems, and let me know when you have questions.